All right, y'all. So like I said, 9.4 deals with logarithmic functions. And I guess the best thing to describe a logarithm in a long-term, a logarithm basically is an exponent. Okay, so if I know the base and I know the result that I get, I can find the exponents, and that's what these logarithms do. So first, let's recall the exponential stuff. So when we had something like a to the x equals y, this is exponential. So remember, a there, a is what we call the base. X is the exponent. And then y was the result. So if I gave you a number raised to an exponent, you multiplied that number ever how many times the exponent said, and you got your result. So an example of that would be something like 2 to the 5th. Which was what? 2 times 2 times 2, 5 times. And if you multiplied that out, you would get a 32. So we're going to be given a base and the result, and we're going to find how many times we had to multiply that base together to get those results. So that's what the logarithms are going to do. So the basic format of a logarithm is they'll write the word log, L-O-G, short for logarithm. You'll have a little subscript that'll be a number here. And then right here, we'll have our result, and that's going to equal our exponent of x. So I'm just rewriting this exponential using that log. So the a is still the base. The y is still the result. And y'all, the x is still the exponent. Okay, so let me show you an example of that. What if I had log of base 3 of 27? So y'all, let me ask you that. What this problem wants me to find, they're giving me a base of 3. That's my 3. I don't know the exponent yet, but I know that that 3 raised to whatever exponent that is has to equal 27. So y'all, I ask y'all, what number do I need to make this true to be put in for that exponent?
3.
3. So since 3 is the exponent that I raised 3 to get 27, the log base 3 of a result of 27 would equal 3. So notice, all we're doing on these, y'all, is finding exponents, okay? So let me give you another one of these before we sort of play with graphing them. And then we'll do a lot of examples finding logs. So y'all, what about this one? How about a log base 5 of 25? So what exponent would y'all raise that 5 to turn it into a 25?
2.
Oh, I think you're right. What did you just say?
2.
2. Yeah, because 5 squared equals 25. So if you want to check these, if you want to check them, you take that base 5, raise it to the exponent you just found, which was a 2, and then that 5 squared has to equal 25, which is true. So y'all, that's the basic breakdown of what a log is. Now, on the front of your calculator, there's two log keys. One of them on the front of that calculator to the left of the 4, I think it is, or the 7, there's one that says log. That is really a log base 10. So if they don't write a number right here where that base goes, it's automatically a 10, okay? Well, let me let one in. Now, the other special log on your calculator is one that is a LN. And it's to the left of the 7, I believe. It's right under the log button. This LN is a special log. It is a log base E. So that little E we was playing with last week is the base of this LN log. So this one's actually called the common log. And the one with the E is called the natural log. Now y'all remember, it looks like this on the calculator. That is not an I. If you put a capital I and an N in MATLAB, it'll mark it wrong. You can use a small L and an N for that natural log. Once you punch it in MATLAB right as an LN, it'll make it bold and bright, okay? So that's how you know if you're writing in the log right and the LN stuff. So these are just two special logs that are on the front of the calculator. So what I want to do is show you how you would do a problem like this, log base 3 of 27 in the calculator. Because the one on the front, that log and that LN only work if you got these bases. So on the calculator, to do logarithms. All right, so it depends on how old y'all's calculator is. So I'm going to share my screen from my calculator here. And we're going to play with that one I just said, log base 3 of 27. So if your calculator is new enough, you should be able to hit the math button. And when you scroll down that math button, you'll come to where it says log base. If you hit enter on log base, it'll bring up the log, and then it'll have a spot for you to put the 3 for the base, and then arrow over and put in 27, which was that result. So now doing this, when you hit enter, you get that 3 like we was looking for, that exponent. So y'all, I'm going to ask y'all this. Do any of y'all got calculators that are not showing that feature on the math button? So are any of y'all using, say, an old 83 or an older 84 that don't have that option? Well, I'm not hearing nothing, so I guess everybody's got that option on the calculator.
Seems like it.
Okay. So on the calculator, to get logs, we hit math. And then we arrow down to log base. But there is other ways that are not too hard if you don't have that feature. But since all y'all are saying we got that feature on our calculators, we'll be good at that. All right, so before we play with the logs, they wanted us to see what a graph looks like. So what we're going to do here is graph y equals log base 3 of an x. So I will say this. These are logarithmic graphs. Logarithmic graphs are inverses of the exponential graphs, okay? So the exponential we did last week, remember them exponential graphs sort of hug that x-axis, went through 0, 1, and then they sort of curved up. That was our exponential. You know, these logarithmic graphs, they sort of hug the y-axis. They'll go through the point 1, 0, and then they sort of curve to the right. So they're almost opposite the exponential graph since they are logarithmic. Now, they all go through that point, and I'll show you how they all go through 1, 0 on the logs, okay? So let's say I'm going to make me an X and Y table for the one we got shown. Oh, and I'll go out about 5, y'all. So y'all, let's think of this. If I put a 0 in for the X, well, there's no exponent that I can raise 3 to turn it into a 0. And if you push log base 3 of 0 on your calculator, it's going to give you an error. So this one does not exist. So our X values, that means, have to be greater than 0. You can't turn a number 3 into a negative number also. So we don't want negative X's over here, okay? All of our X's on the logarithmic graphs will have to be positive values. And that's just because you can't turn numbers into negative numbers, okay? So let's see. The smallest X I'm going to use for this one is a 3. And y'all watch this. So answer this. What is log base 3 of 3 equal? So what exponent would I raise 3 to turn it into a 3?
Zero.
Well, remember 0, that turns numbers into 1. So you got this. So I got 3 to some exponent equals 3. What's that exponent?
1.
So when X is 3, my Y value is 1. So here we go. We're over here at 3, 1. Now, what if I did an X value of 1? So what exponent would I raise 3 to turn it into a 1? Do y'all remember what exponent I'd put here? Oh, and y'all just said it while ago for the other problem. How about any number to this certain exponent will equal 1?
0.
0. So over here at 1, 0, I'm crossing the x-axis right there. So that's why every one of these, if your x value is 1 for the result, then that means the exponent or the y value has to be a 0 for these. So remember, we're just looking for exponents on these. So the next number I'm going to use is a 9. So I'm using numbers that I know I can multiply 3 to get, okay? So what would the y value be for this one? Log base 3 of 9.
2.
3 to 1 exponent is going to equal 9. And I thought I just heard someone say something.
2.
2. So y'all way out here at 9, this thing's barely up to 2. So what it's going to do is going to come up that y-axis, hit that 0, 1, and then just sort of go uphill to the right. So it's going to have that logarithmic shape, okay? So watch this on your calculator. Let's see. We'll go to our calculator. So I'm going to go to y equals. So since y'all got log of base, for this one, we would hit math. arrow down and get our log base. Once I got log base, I'm going to hit enter. So that was a log of 3 for the base. And then remember the X. And then what I'm going to do, y'all, is hit graph. So see, there you go, sort of uphill and to the right. And if you look at the table, my wife, see all these errors. So anything from 0 or less on that negative side is going to give you an error, because you can't turn those base 3s into negative numbers and 0, okay? And then we got the smallest point would be 1, 0. Notice all the multiples of 3, I get nice numbers like 3. I got a 1 for that Y. If I arrow down, remember my next number was 9. So that's going to be the next nice number. 9 gave me a 2. Next one would be 27, because 3 to the third is 27. So just remember, on these graphs, we're looking at exponents, okay, for our solutions. All right, so there'll be a few graphs where you just play with those. Easiest thing, punch them on that calculator, because you don't have to graph them in MathLab. You just got to pick one of those 4 pictures. So now for these examples, we're actually going to find the logarithms. So the first 3 we're graphing, starting at 4, you're going to find logarithms. So y'all, let's try this in log base 7 of 49. So y'all, what would that exponent be that I would raise my 7 to make it a 49?
2.
And that'll be a 2. So the answer MathLab ones, just that 2 and move on, okay? Anyone need me to explain these more, or you're all getting them? All right, log base 6 of 216. And y'all remember, if you want to punch them on the calculator, hit math, arrow down to log base. Or you can take that 6 and start multiplying it and see how many times you got to do that before you get me a 216. All right, so what's that exponent?
3.
All righty. Make that more confident sounding and you'll be good to go, right? Remember, if you want to check these, take the 7 for the base, square it, you'll get 49. Take the 6 for the base, cube it, you'll get 216. All right, how about a log base 9 of 9? What exponent would you raise that 9 to keep it a 9?
1.
So good job. That is definitely a 1. And y'all, actually, there's a little property on that that says if your base matches that result, then the answer is automatically going to be a 1. All right, let's see what we do here. This is a log base 3 of 1 over 81. So the calculator, you would punch this in on that log base. It'll knock it out pretty quick. But y'all, I'm going to show you. Anytime you got a log with a base that gives you a result of a fraction, that's going to be a negative exponent. Because your 81 is under a 1, that's going to make the exponent automatically negative. And then you figure out how many times do I multiply 3 times itself to get to 81. So y'all, how many times would I multiply 3 to turn it into an 81?
4. -4.
So that's going to be a -4 since that's a 1 over 81. So let me show you how this happens when we check this. So I'm going to actually check this one for you. I would take my base of 3, raise it to an exponent of -4. Well, there's a rule about negative exponents that says if you have a negative exponent, to make the exponent positive, you put it under a 1. So, and then you change the sign of the exponent. So if it's 3 to the -4, I put it under a 1 and make the exponent positive. And then the 1 stays on top, and then 3 to the 4th on the bottom gives me my 81. So that's the reason if you have any fractions like this, 1 over whatever, that's going to give you a negative exponent, okay? So this section sort of brings back all your knowledge. So this actually goes by the property that says any number to a negative exponent becomes a 1 over a to a positive n. Okay, y'all? And y'all seen one last week where we had a fraction to a negative exponent. We flipped the fraction on that one and made the exponent positive. So it's like you're flipping both, okay? All right, y'all, let's see what we got next. Oh, let me see. How about ln of 1? So remember, this ln of 1 is really like a log base e of 1. So what exponent would I raise e to turn it into a 1?
1.
Well, let's see. E to the first.
0.
Or 0.
I just heard it. Y'all just said what? A big O? 0 on that. So the ln of 1 is 0. Now y'all can do this on the front of your calculator. Right by that 7, there is a ln button. So let me pull mine up and show you. So yeah, right on the left side of the 7 is the log button. Remember, that's a log base 4. Any other base, you would have to go to the math menu and go down and find log base. And right under it is the ln button. So remember, that's an ln when you go to math lab. So ln of, what was it, 1 on that? And notice when I hit enter, I get my 0 exponent, okay? So that's the nice thing about this section is you get to use the calculator a lot. Because doing logs and natural logs by head is just hard to do. All right, y'all do this one. Log of 1 over 10. So remember, you don't see a base by the log. So since I don't see a base by that log, it is a base 10. And then I got 1 over 10. So that's a fraction, which means my exponent has what sign?
Negative.
And then since that's a 10, to turn it into a 10, that means this exponent is what, a negative?
1.
-1, good job. And it goes back to that base, matches that result, gives me a 1. So they're not too bad once y'all sort of understand that we're just looking for exponents, right? So let's see, that was -4, 0, -1. All right, so let me turn it up a second. Log base 3 of 3 to the 4. So here's my base 3 sitting here. I'm looking for the exponent that'll give me a result of 3 to the 4. So by default, what's that make that exponent have to be? If these two sides are going to be equal.
4.
There you go. So a property on this one says that anytime a log has a base that matches the result raised to an exponent, the answer is always going to be the exponent, okay? as long as these bases match. All right, log base 5 of the cube root of 5. So let's recall on that one. That's a radical. So y'all, so any radical can be written as a fractional exponent. So here's my A. Since we're looking at roots like a square root, cube root, to rewrite roots as exponents, you put a 1 over whatever that root is. So that would be what? 1 over the n. So we rewrite radicals as fractional exponents. So that's probably the first thing I would do to this one is rewrite that radical so that I get a log base 5 of 5 to the 1/3. So my exponent becomes the radical rewritten. And since I had a 5 under the radical, the 5 became the base of that exponent. So once you get the radical converted into a fractional exponent, what does that give me? The log base 5 of 5 to the 1/3.
One-third.
1/3. Still following that property, right? A base matches that same base when the result raised to an exponent will be that exponent. Okay, what if I did this? Log of 10 to the -4. What if I did something like that? What exponent will that give me? And y'all, what you got to think about, I don't have a base written down here, so what is it by default?
Would it be -4?
It'll definitely be -4. Because remember, that's like a 10 sitting down here. Since they didn't write the base, that's a 10. So you got a base of 10 raised to that result of 10 with exponent of -4. Good job. That's always going to give you that exponent, okay? So I wanted y'all to see all three of these were basically the same. My answers were all those exponents, okay? The only one that was tricky was rewriting that radical one. So how about a log base A of a 2? So you're starting with an 8. So this one sort of goes back and shows you how you're getting these fractional exponents, I guess. This answer will give me a fraction. So y'all check this out. Since the result is smaller than the base, you're automatically going to put a 1 over what we need here.
3.
3. Because to turn an 8 into a 2, you would take a cube root. Well, remember, the fractions for the cube roots are the exponents, okay? So anytime, so if this would have said been a 9 and a 2, a 9 and a 3, to turn a 9 into a 3, you'd do a square root, which would have made that a 1/2. So basically it's 1 over what you got to do to the result to get to that, okay? So it's sort of backwards. All right, y'all, let's see what we get on 14. Log base 23 of 1.
Zero.
So that's definitely a 0. 23 to the 0 power equals 1. And that means a log base A of 1. I don't care what that base is. If that result sitting there is a 1, then that exponent has to be a 0. All right, y'all, let's see. Let me move my camera down just a little for these last two on this page. 15 is a ln of e to the -5th. So remember what that ln is. Remember that ln is really a log base e. So this problem is really a log base e of e to the -5th. So what's that giving us?
-5.
-5. Because my base matches that result to an exponent. Good job. All right, try this one. ln 5th root of e. So y'all, let me rewrite this as a ln of e. What exponent would we put behind that e if we're converting that radical?
Can you move the paper up, please?
Oh, do I need more like that?
Yes, sir.
Okay. So I brought over my ln and my e for my base. Now I'm going to rewrite that radical as a fractional exponent. So what would we put for the actual fractional exponent?
1/5.
1/5. So I got an ln of e to the 1/5. What would that give us? Oh, let me write that out for y'all. Log e of e to the 1/5 is going to give me
Is it 1/5?
1/5. Okay. So remember, we want y'all to realize that the ln is a log base e. So when you rewrite that radical and you see this, automatically want y'all to realize this is the log base e of e. So they're sort of following that rule we had. Oh, I don't think I wrote it way up high. But those always are going to equal the exponents, okay? All right, y'all. So next, let me flip my paper. So next, we're going to convert from exponential to logarithmic. So we're going to convert from exponential to logarithmic. So remember, exponential was a to the x equals y. This is my exponential. My logarithmic, so this is true. This arrow, when it's got a double side like that, that means if and only if the log base a of a result of y equals the exponent of x. This side is logarithmic. So they're going to give me something that looks like this exponential, and we're going to rewrite it using a log by putting our base where the base goes, the result y where the results go, and then the exponent x where the exponent goes. Okay. So now I'm going to go from exponential to logarithmic, and I'm just going to place stuff where they got them. Okay. So how about this one? Convert to logarithmic. And they give you 3 going each way. So let me play with these. So the first one, 10 to the 4 equals 10,000. Writing that with a log. My base is the 10. It's the base for both of these. So bring down that 10. My result of this logarithm is the 10,000. So write the 10,000 for your result. And that's going to equal the exponent of 4. Now, you could probably write this in MathLab as just a log of 10,000 equals that 4. Because remember, if I don't write a base, it's automatically understood to be a 10. So if I get log base e's or log base 10s, I can write them with log or the ln, okay? All right, y'all, 18, 243 to the 1/3 equals, oh, that's a 5. 243 to the 1/5 equals 3. So make sure you make that a 1/5 for this one. That way it's still true, okay? All right, y'all, so I would have my log. My base is the 243. My result is the 3. And remember, when your base is a lot bigger than the result, you're going to get fractional exponents. And once I write my exponent over here, this is now a true statement. If you take the 5th root of a 243, you will get that 3, okay? All right, so I'm going to let y'all sort of help me on this one. I got e to the 5th equals r. So let's start out our log. So y'all, what is the base of that log?
E,
So that's going to be the e. What's my result?
the R,
And that's going to all equal
5.
there you go. Now, since that's a log base e, I can also rewrite that one in MATLAB as a ln of r equal to my 5. Now, it will let you do a log base e, but remember, you can shortcut the log base e as an ln, and then you can shortcut the log 10 as just a log. All right, p to the k equals 81. So here you go. What's the base of this log? Oh, y'all don't like it? Okay, I heard a p finally. All right, what's my result?
81.
And log base p of 81 equals, I guess, the, okay, there you go. So for 17 through 20, they just want you to rewrite. Now, once you get to 21, we're going the other way. We're going to convert to exponential. And y'all, I'll tell you why they're getting y'all good at this. When we hit section 9.6 and we start solving equations, the way I solve exponential equations is turning them to logs. And the way I solve the logs is by turning them into exponential. So we go both ways when we're actually working these equations. So y'all, let's see. My first one is log base 5 of 125 equals 3. Writing that as exponential, my base is 5. My exponent is 3. And that equals a result of 125. So I'm just following this path, putting the a where it goes, the x where it goes, and the y where it goes, okay? And then the same thing going back, a where the a goes, the y, and the x. All right, y'all, so 22 has log of 0.1 equals -1. So remember, this is a fraction, really. 0.1 is the same thing as 1/10. So that's why that's a negative exponent. So what's my base?
One-tenth.
Oh, now that's my result, remember? So remember, if you don't see that little number down here, what is it by default on the log?
10.
So that's definitely gonna be 10. Exponent is the -1, and then that's gonna equal your 1/10, okay? So y'all don't let us fool you when there ain't a number there. You gotta treat that as a 10. All right, let me move this down just a little bit so we can get these bottom ones. All right, 23 was an LN of 52 equals 3.9512. So what I need first is, what are y'all putting here for the base? Y'all, that's an LN sitting there. So what do we say the base was for the LNs?
Is it E?
So it's an E. So remember, a log by itself is a 10, a LN by itself is an E. My exponent is a 3.9512. And that equals a result of 52. So y'all just got to get used to this LN being a log base E and the log being a log base 10. All right, here y'all go. A log base M of a capital T equals a -y. Now, y'all, when you do this one in Math Lab for 24, you got to keep little letters small and capital letters capital on that, okay? All right, y'all, so let me see what's y'all's base.
The little m.
All right, what's the exponent?
-y.
And M to the -y equals
Capital T.
capital T. Okay. Yo, that's the trick on those. Just get used to rewriting them and getting used to what the bases are, the results, and those exponents on those, okay? All right, so now they want y'all to play with the calculator. And everybody's got a common log on front of those calculators. That's the one on front that says log. So on these examples, they want us to use a calculator to find the common logs round to 4 decimal places. All right, so y'all, everybody's got these on front of their calculators. So how about a log of 64? So let's see, I'm gonna go to mine and show you on mine real quick. So I'm gonna do that. So log of 64, right next to the 7, hit log. Punch in 64. And all I gotta do now is hit enter. Now notice I get 1.806179974. The 1 is in the 4th digit spot. So I look at the 5th digit spot. So since that's a 7, that's bigger or equal to 5, I got to round the 1 up to a 2. So that would give me a 1.8062. Okay. So you got to round these 4 decimal places. All right, y'all. Log. Now let me show you what we got going on here. Remember, this is a base 10. So 10 to the first is equal to 10. 10 squared is equal to 100. This is 64. 64 is in between 10 and 100. So since 64 is in between 10 and 100, the exponent has to be between a 1 and a 2. Well, y'all, 1.8062 is in between 1 and 2, okay? So look at this one. log of 2. Well, 2 is less than 10. And since that's a base 10, they don't write the 10. And 2 is less than 10. That means my exponent will be less than 1. So if I was to punch that one in and round it, y'all, let's see. Log's on front, so hit log, put in a 2, and enter. I get 0.30102. So since 2 is in the 5th spot, the 0 that's in the 4th spot will stay the same. So that'll be 0.3010. So really for these examples, they're just wanting y'all to get sort of good on that calculator. All right, y'all try this one. Log of a negative 36. So anyone got a calculator that can punch that in? All right, so let's go to mine. So I'm doing a log of a negative 36. Y'all, when y'all punch that in, remember that
Okay.
H is negative on this, like my graphing will go. Anytime you try to take a log of a negative number, you're going to get an error message. So what that means is when I go back to put this in MATLAB, on this problem, they'll have a part that says does not exist. So it does not exist in the real world. I cannot take a 10 and raise it to any exponent and turn that into a negative number. That's impossible. So anytime you got a log of a negative number, you're going to have to put does not exist. All right, same thing with the LN button. LN of 53. And I'm going to round this 4 spots. So y'all, I would go right to my calculator. On the left side of the 4 is the LN button. So hit LN and then punch in 53. And when you hit enter, I was on that negative one still. LN 53. Hit enter. So that gives me 3.9702. The 2 is in the 4th spot. Got a 9 in the 5th spot. So that means I round the 2 up to a 3. So I get 3.9703. All right, so I'm going to zip down. Number 29 is doing the same thing. Let's try 30. LN of a negative 1.19. What do y'all think that's going to give me?
An error.
It's definitely an error. So this one does not exist. All right, y'all. So then finally, near the end of this section, they want us to find logarithms. So find the logarithm using change of base. So this is the way you would have done it in the beginning when I said there was an alternate method. Now, if you got log base on yours, if you got this button, if you got math, and you got log base, you don't need to do this, okay? This is only for the people that don't have the math and the log base. What you would do is what we call change of base. So change of base is when you got a log base A of B. This is not a 10 or a E, because remember the 10 or E, I would just use the log on front of my calculator. This is when you got a base other than a 10 or an E. To find the answer, you would take the log of the B which is the result, and divide by the log of the base, which is the A. And y'all, I'll show you both ways when I do this example. So this is how you would have to put stuff in on the calculator if you don't have the log of base, okay? So watch, I'll show you that both ways we'll get the same answer. So we're going to estimate this out 4 decimal places still. So the log of base 6 of 18. So y'all, I'm going to go right on my calculator here. I'm going to clear everything. So if you got log base, you would hit math, scroll down to your log base, hit enter, and then put a 6 in for your base, arrow over, and put an 18 in for your result. So once we hit enter, rounding that 4 spots, looks like I'm getting a 1.613. Oh, that 1's in the 4th spot. Got a 4 behind it, so it's going to stay a 1. Now, the other method, you can do the log of the result, which is 18, close parentheses, and then divide by the log of the base, which was 6, close parentheses, and hit enter. I still get 1.6131, blah, blah, blah. Now, y'all, here's what's cool. The LN can do that. I can do the LN of the 18, close parentheses, divide by the LN of the base, which was 6. And when I hit enter, I'm still going to get 1.6131. So when you change the base, it don't matter whether you use the log or the LN. But if you use a log for the result, you got to use a log when you're dividing by the base. As long as those match up, it'll spit out that answer every time. So y'all, we'll have a few problems where we go through doing that. So y'all, I'm going to give y'all one to do real quick and see what y'all get. So this would be like 35. Do me a log base 700 of 30. And y'all round that thing out about 4 decimal places.
.5192.
So 0.5192. Good job. All right, y'all. So they got through that. So now our last thing they want us to do is do another graph. They had like 3 graphs in the beginning. Now this last graph is because they want you to do the inverses. So they want us to graph both functions, just to see how the graphs do, okay? So f of x is going to equal 2 to the x. Now remember, I said the logs were inverses of the exponential. So remember, that'll be f negative 1 of x. Remember that negative 1 means this is the inverse. In the inverse equation would be log base 2 of x. So for y1 on my calculator, I would graph my 2 to the x. In y2, I would use my log, my base log feature on the calculator and put in my log base 2 of x. Now they'll give you 4 pictures. So let me go graph these and show you what we get. Now, I'm on a newer calculator, so when I hit y equals, let me clear that from my y1 from while ago. So y1 will be 2 to the x. So that'll be 2 exponent x. So my calculator, since I got a newer one, will make that graph blue. Now my other graph was log base 2 of x. So I'm going to hit the math, arrow down to log base, hit enter. I put in my 2, arrow right, and put in my x. Now, y'all, if you do not have a newer calculator and you find out you have an old one, for you to do this, you would have to do the change of base. You would put log of x, close parentheses, divided by log of 2, and then close those parentheses. So the change of base will work on this if you need to. All right, y'all, so let's just hit graph. So there's my exponential. Remember, it sort of has a horizontal asymptote on the x-axis, and it goes up towards positive infinity. It does not cross the x-axis. And then my red graph is my log graph. Notice, it cannot cross over the y-axis because those results can't be negative values. So that's why it does sort of like a vertical asymptote on the y-axis, comes up to the point 1, 0, and then slowly increases to the right. So y'all, you'll have 4 pictures. You'll have to draw. I mean, you don't have to graph these. Just pick one of the 4 pictures that has your 2 graphs like that. So I figured before we left, I'm going to do a little review with y'all over what we went through today. See what answers y'all give me. So for one, what is the answer for log base 30 of a 1 going to give me?
Zero.
So that's going to definitely be a 0 all day long, okay? How about a log of 10? So remember, there's not a base shown there, so you got to remember what that is. And then tell me the exponent you would raise that to get that 10 in that result.
1.
So that is definitely a 1. So remember, that's like a log base 10. Anytime they match, it's going to be a 1. All right, y'all. Log base 5 of 1 over 25. First of all, what sign would that one have?
Negative.
So it's going to be a negative.
2.
And it's going to be a negative 2. Good job. ln of e.
One.
So there you go. That's like a log base e, member. And e with a result of e is always going to be 1. So that's pretty much like number 2. All right, staying on the LNs. I'm going to do an LN of a negative 125. Oh, I figured y'all be quicker on that one.
Does not exist.
Does not exist. All right, let me finish y'all out on a log base 7 of a negative 343. Oh, y'all taking too long.
Does not exist.
Does not exist. Y'all, if that thing's negative, I don't care what the base is and all that fun stuff. If that thing's negative, it does not exist. You can't take any number and use exponents to turn it into a negative number, okay? So y'all, that's 9-4. Next, we hit 9-5 on Wednesday. That's where we learn properties of exponents. And those are going to come in big play when we solve these equations eventually. And the exponent rules follow the logarithm rules in the long run, okay? Because remember, logarithms are really exponents, okay? So y'all go have fun with that calculator, play with them exponents. And I don't think you'll have much trouble on them because they're not too bad. And like I said, that calculator does a lot for us. So y'all, do I have any questions? All right, so y'all know we just got about 3 weeks of having fun left doing this, right?
Yep.